Hi, in this video we're going to discuss the Safari Modern Analog tool. Now, there's been a wealth of information that's become publicly available over the last 10 or 15 years from services such as Google Earth, NASA Whirlwind and so on, which has basically placed world-class remote sensing data for the entire globe at the fingertips of Earth scientists. Now, a big challenge with this is actually finding the right locations to use as analogues. So we put together during phase 2 a little project to build a tool that would enable you to be able to select the right analog. So if we start at the sponsored dashboard section here and we click on Modern tool here, you can also get to it at the top here. And what you will basically see is a Google map view of the world. We can click between map and satellite at any time. And there are two gross depositional environments available. Obviously, we can't show modern analogues for deep water systems on Google Earth or Google Maps. So if we start out with the paralic and shallow marine, what we see is the classic threefold WTF classification: wave, fluvial and tidal. And we've used the first two orders of subdivision based on the Ainsworth et al. Classification. So basically a system that's completely wave dominated would occur down here. A system that's fluvial dominated, such as the Mississippi Delta, would occur up here. A system that is tide dominated, such as the Ganges, would appear down here. And then there are various combinations of fluvial with wave influence, wave with fluvial influence, and so on. So ultimately we will check the type of shallow marine system that we want. So maybe we're interested in wave dominated systems and perhaps a little bit of wave fluvial. I can filter for the type of basin I want, and you can already see that a large majority of the world is actually wave dominated. So perhaps we want to be a little bit more selective and just look for wave fluvial systems. So these pins are now showing me places in the world that satisfy that criteria. Now I might want to filter those on to basin types. So perhaps I'm only interested in fallen basins, and perhaps I'm only interested in equatorial climates. And what I see now is these pins are now showing me parts of the world, 5-kilometer sections of the Earth's coastline that satisfy those criteria. And at any time I just hold the button down here and I can zoom in. And I can go and look at these 5-kilometer long sections. If I turn it on to satellite, I can then zoom in and I can decide whether the things that have been highlighted by the search tool are an appropriate analog. Now, it should be understood that these are algorithms based on a combination of wave buoy data, tidal models, and fluvial discharge. So they are simply algorithms that are combining those processes in a GIS format. So not necessarily all of the time is the algorithm correct, but our benchmarking suggests that it's right about 85% of the time. So it should enable you to find suitable modern analogues for your ancient systems. And it's also, the beauty of this is that the results are fully auditable. So ultimately, you know, when people say, why did you choose that part of Taiwan as a modern analog? You can say that basically because I used the Safari data. We can search for continental systems rather than, just going to reset that. We can search for continental systems rather than shallow marine systems. And here we use a similar threefold triangle approach. We basically classify the world into systems that are fluvial, aeolian or lacustrine. And basically I have here, I can have some fluvial with some aeolian influence, and we'll see the parts of the world that satisfy that criteria. Again, I might be interested only in extensional basins or intracratonic basins and extensional basins, or I might be interested in fallen basins. And again, I can sort of zoom into any one of those areas. Let's select an area up in here that satisfy those criteria. I can flick it over onto tidal and I will find some nice fluvial and aeolian processes interacting in here. Again, the tool is only a guideline. It's not always going to be 100% correct, but it will help you to find areas and help you to filter areas in the world. And on this page there is also a tab here called the background, which basically just provides a little bit of detail from Bjorn Nyberg's PhD about the layers that have gone into building this up. And we can see here, this is a map of all of the world's basins. This is a map of all the world's basins with a climate overlay. This is the map of those basins with a tectonic overlay. This is the classification of the shorelines into 5 kilometer blocks. These are the mean depositional shorelines. These are the areas of the world that are lakes. These are the areas of the world that are aeolian, and these are the areas of the world that are considered to be fluvial. So ultimately, we hope that you're able to use the Modern Analog Finder as a tool to help you use modern analogues. The information that is very, very powerful that we get from Google Earth and Google Maps. This gives us a very, very clear two-dimensional planar view of what's going on. And a lot of the time when we look at outcrop analogues, they're cross-sectional. So combining outcrop analogues with suitable modern analogues using the same linked standard enables us to produce a really nice 3D picture and a good 3D conceptual understanding of what our depositional system looked like. Thank you.